So guys, you have noticed that when you switch off some electronics like the lights and the speakers, they continue operating briefly and then they go off. So today I'm going to show you why. You look at this component here. This is a capacitor, and I'm going to solder this cable to the positive terminal of this capacitor and solder the other white cable to the negative terminal of this capacitor. These are the terminals of the capacitor here. So let's solder. I'm going to connect this to the positive and connect the negative of my meter to this side, like that. Then switch on my meter and turn it to DC voltage. Then after that, I'm going to connect my power supply to power and then switch on. Look at the reading on the meter. Now our power supply is connected to power, and you can see the DC reading on the clamp meter, which is measuring the voltage on that capacitor, is rising. So what is happening is that the capacitor stores energy, and that energy is the one which is going to our electronic components. This capacitor has a rating of 400 volts, 82 microfarad. You can see the voltage across the capacitor keeps on rising, so the capacitor is charging as the power supply is supplying power. So if this power supply is connected to an electronic equipment, that equipment will be now operating as the capacitor charges. You can see now it is at 200 volts DC. The voltage across the capacitor is now at 367 volts. The voltage across the capacitor terminal is now at 398 volts. You can see. So we can say the capacitor is now fully charged. Let's see, when we disconnect our capacitor from power, what happens. We are going to switch off the power and remove our power supply from power. Now let's look at the voltage across the capacitor terminals. It keeps on falling. Our capacitor is now powering the circuit. This is why you see some electronic components, when they are switched off or they are disconnected from power, they keep on operating briefly or for a short period of time and then they go off. This is because of the presence of these capacitors. These capacitors store power temporarily and then discharge their stored energy when the power is disconnected, hence causing the circuit to be powered for a short period of time. After some time, the capacitors are depleted. If we connect a resistor at the positive terminal here, we are going to connect a 10 kilo ohm resistor to this terminal here. We have connected the resistor in series with the terminals of the capacitor. Let's see how the voltage drops. The voltage is dropping from 400 volts when we connect a resistor. So basically, this resistor is consuming the energy stored in that capacitor. You can see the voltage keeps on dropping. After some time, the capacitor will discharge to 0 volts. Now we can see the equation of discharging of the capacitor. The voltage across the terminals of the capacitor is called VC and is given by V exponential minus T over RC, where R is the resistance of the resistor connected in series and C is the capacitance of the capacitor. So we can see when the capacitor will discharge to a voltage of 1 volt. So the capacitor will discharge to a voltage of 1 volt, where the initial voltage of the capacitor is rated at 400 volts. So 400 volts exponential minus t, it is the time that we want to see for how long will your electronic equipment operate when you disconnect the power or you switch off the power over. Our resistor here is 10K, which is 10 times 10 power 3 times our capacitor is rated at 82 microfarad, which is 82 times 10 power minus 6. So if you evaluate this formula, you will find that t is equals to 5 seconds. It will take around 5 seconds for the capacitor to discharge to a voltage of 1 volt. That is where your equipment operates for some time after you switch off the power, and then it goes off. The energy stored in the capacitor is utilized to run the equipment for a few seconds, and then after the capacitor is fully discharged, your equipment goes off. You can see the voltage across the terminals of the capacitor after a few seconds is 0.